There are infinitely many ways that you can graph a linear equation. One of the most common ones being y equals mx plus b. So for some of you that are not familiar with this equation, y equals mx plus b is an equation that is used to graph used to graph on a plane, like a coordinate plane, or you could just solve for y. So m, the coefficient, is the slope. Then b is your y-intercept. And your y-intercept is when you, like, per se, if you have a coordinate plane here and you graph a line using y equals mx plus b, your b will be the point where it will cross the y-axis. See, like, this is the y-axis, and the b is where it will cross the y-axis, like this point. Like if I graph a line here, this point will be your y-axis because your y-intercept, because that's where it crosses y. And your slope is more like an angle, not like an angle like 60 degrees, like not like that. Don't get confused with that. The slope is kind of like a slant, like per se x and y. Like if I graph y equals 2x plus 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So like your y-intercept would be 3, right? Because this is your b. And 2 would be your slope because it's the coefficient of x. So you already know where your line is going to cross, but you need to have, like, in some questions they give you a specific coordinates, like 3, 1. And sometimes you can just make a table, like x and y. Like when you use a table, you have to use some values to make this equation true. You just plug in values sometimes. Like, I don't know, x would be 1. And then, so you plug it into equation, so it would be y equals 2 times 1 plus 3. So it would be 2 plus 3 equals 5. Y being 5. So that's y. And you can use 2 as x, like 1, 2, 3 being the counting numbers. Y equals 2 times 2 plus 3. So it would be 2 times 2 would be equal to 4 plus 3, bringing everything down. And then 4 plus 3 would be 7, with y being 7. So basically, the table, when you have 2 pairs of coordinates, 1 and 5, 2 and 3, that's basically like all you need to graph something. So every time, just to make sure, we'll put 3 on the table. So it'll be y equals 2 times 3. You'll know what I mean when I say we need to make sure once we finish. 2, 3. So 2 times 3 is 6 plus 3. Bring everything down. So that it will be 6 plus 3 equals 9. 9 being y. So in our table here, x is constantly changing by 1, and y is constantly changing by 2. So here we already know. So when I put the table here, it was to see what the slope was, to confirm it. So I was just furthering what most people might know as y1 minus y2 over x1 minus x2. Nah, that was wrong. What most of you might recognize as y2 minus y1 over x2 minus x1. So y2, so an example would be like you have two pairs of coordinates like 3, 2 and 1, 5. So you know that this coordinate is x and this one is y. So you would say, like you would just plug it in. So this is x2, y2, y1, x1. So you would just plug in values. y2, which is 5, minus y1, which is 2, over x2, which is 3, minus x1. Oh, x2 is 1, minus x1 being 3. So it would be 3 over negative 2. That would be your slope. This is just an example, this is something else. So that would be your slope, the coefficient in front of the x. So here, it changes by 1 and 2, right? So here, you would know y2 minus y1 over x2 minus x1. Your change here, 7 minus 5, is 2. So 2 on top. Because this is y2 and this is y1. You could use any pair of coordinates, like in a table or a pair of coordinates. And here it would be x2 and this one would be x1. 2 minus 1 is 1. Slope being 2. And as here, 2 is our slope. And to graph this, we would use a technique called m, which is our slope, equals rise over run. Now here, we would just draw ourselves a little coordinate plane. Y and x. So let's just label our coordinate plane here. One, 2, 3, 4, -1, -2, -3, -4. 1, 2, 3, -1, -2, -3. Okay, so now that we have our coordinate plane, we can graph the equation. So we all know that our intercept is 3. So here's 3. Now, using the rise and run strategy, 3 can be used as like the base of this. So this 3 helps this 2 because the rise over run. So using rise over run, the rise would be 2 because the slope is actually a fraction, 2 over 1, which evaluates to 2. But in this case, the rise is 2 and the run is 1. The rise and the run is basically the slope, because m equals rise over run, which rise is 2 and run is 1. So you would use rise 2, 1, 2. That's going a little bit higher than our coordinate plane, so it would be all the way here to 6. Rise, then run 1. That's one coordinate. So the coordinate here is 6, 1. That's this coordinate. Let's call it coordinate A. And this is our coordinate B for the y-intercept. Now we can connect these. But as you can see, this is only a part of the actual line. We need the whole line. So now we use the opposite. So like now we go like -2 over 1, so we can graph the other part. 1, 2, -2, that's our rise because it's rising -2, which means we're going down. 1, 2, which is here at 1, and then we run -1. Well, no, just 1 over here. So this we'll call point C, and we can connect it. So here I'm just gonna do a scale of the actual version. So this coordinate would be -1, 1. And this would be your y-intercept, which is just 0, 3. And that's all you need to know to graph a line. Well, not all you need to know, because there are, as I said at the beginning of this video, there are infinitely many ways. Like if we can rewrite this equation, like we have this y equals 2x plus 3. We can rewrite this to manipulate it to be -2x plus y is equal to 3. That's another way, but we'll discuss this in another video. And that's all you need to know.